Okay, so let's say, for example, let's say if we want to find the x and y intercepts for f of x equals x minus 5 times x minus 4 times 4x plus 4. Okay, so remember, for your x-intercept, you just make y equal 0. Oh, move that up some. Or in this case, f of x equals 0. Okay, so that just means you have 0 equals x minus 5 times x minus 4 times 4x plus 4. Okay, which means any one of those could equal 0, and that would be true. Yep, so x minus 5 can equal 0, x minus 4 can equal 0, or 4x plus 4 can equal 0. So add 5 to both sides here, x can equal 5. Add 4 to both sides here, x can equal 4. Subtract 4, then divide by 4, x can equal negative 1. So your actual x-intercepts are 5, 0, 4, 0, and negative 1, 0. Remember, you made y equal to 0, so those are your x-intercepts. Okay, hopefully that looks somewhat familiar. And for your y-intercept, you just make your x equal 0. And kind of separate that a little bit. So your y-intercepts make x equals 0. So that means if you have f of 0, that's going to equal 0 minus 5 times 0 minus 4 times 4 times 0 plus 4, which is just negative 5 times negative 4 times 4, which is 80. So your y-intercept is actually the point when x is 0, y is 80. All right, any questions on that one? All right, I'll leave that up. Okay, so the reason we review that is because sometimes they'll call the x-intercept, you'll see them say, find the zeros of this function. So when they say find the zeros, it just means find the x-intercept. Okay. Find the x-intercept will sometimes be called finding the zeros of a polynomial. Okay, so if you see them say find the zeros, they're just saying find the x-intercept. Okay, so let's say, for example, if you want to find the zeros of, I'll put it down, should be able to fit here. Let's say f of x equals x minus 2 times 2x plus 1 times x minus 5 times 3x plus 2. Yeah, should have put it underneath like I originally planned. (3x plus 2). There we go. Okay. So find the zeros. You just set each one of those to 0.